Hi, and welcome to another lesson in the physics video series. Today we're going to be discussing the general solution for all collision problems that are elastic collisions. An elastic collision has both masses in the two-body problem bouncing off each other and not sticking together. We're going to use the conservation of energy relation and the conservation of momentum relation to develop two equations for the velocities after the collision of masses 1 and 2. So we will be looking for v1 prime and v2 prime. We're going to start with a general solution, then we're going to go into specific numerical examples. Okay, let's get started. As we mentioned before, we're going to use the conservation of energy relation and the conservation of momentum relation, and we're going to do a system of equations whereby we combine them in such a way as to solve for v1 prime and the v2 prime. As you can see here, we have two equations with two unknowns, and since these are complicated expressions to combine, I'm going to show you below a development, but I'm not going to review the step-by-step algebraic steps as to how I achieve the final general solution that you see here in this red box. This red box represents mass 1 because mass 1 was the red car. This is the general expression for v1 prime, which is the velocity of mass 1 after the elastic collision. You could see that there's a mass ratio in front of v1 and a mass ratio in front of v2. If I take this expression and continue to combine it with previously developed expressions, as you see here in this algebraic manipulation, I will eventually obtain the formula in the blue box, which is the v2 prime, the speed of the blue car after the collision. This is the general expression for v2 prime, which is the velocity of mass 2 after the collision. You can see again that there is a mass ratio related to the original speeds of the cars before the collision. As you can see here, I have extracted the red box, which is the v1 prime formula, and the blue box, which is the v2 prime formula. I've created an Excel calculator based on two masses. I can then determine what the final speeds after the collision will be if I put inputs right here into the v1 and v2 spots. We're going to use the collision simulator that we've used in previous videos. So let's select for these two masses a certain speed like v1 being equal to 5 meters per second. And let's say that that collides into a second car that is at rest. What will be the prediction based on these two formulas of the final speed of both of the cars? When I hit enter, you'll see that my calculator immediately input all of this data into the two formulas, and it says that v1 prime will be 0 and v2 prime will be 5. So the red car traveling at 5 meters per second will hit the stationary blue car, and the red car will stop, and the blue car will absorb all of its momentum and energy and continue off at 5 meters per second. Let's run that in the simulation. Here you can see I've made the masses of both cars equal to 1 kilogram, and I'm going to set the initial velocity of the red car to be 5 meters per second to the right, and the blue car will be at rest at 0 meters per second. Let's start the simulation and see what happens. The prediction said that this red car moving at 5 meters per second will stop, and the blue car will shoot off at 5 meters per second. There will be a complete or elastic transfer of all momentum and energy. Let's take a look. And there it is. We can see very clearly that the red car, which started at 5 meters per second, is now at 0 meters per second after the collision, and the blue car, which started at 0 meters per second, is now at 5 meters per second. And we can see that in summary here. v1 equals 5 meters per second, v1 prime was 0 meters per second, v2 was 0 meters per second, v2 prime equals 5 meters per second. Let's try another combination where the cars hit head-on. Let's say v1 is traveling at 5 meters per second and v2 is traveling at negative 5 meters per second. It says here that v1, which is at 5 meters per second to the right, will have a velocity after the collision at negative 5 meters per second, which means that it goes left. And v2, which was heading to the left at negative 5 meters per second, will have an after velocity of positive 5 meters per second. So this says, very simply, that when the two cars hit at the same speed from opposite directions, they will perfectly ricochet off of each other and go backwards in the opposite directions at the same speeds that they came in with. Let's take a look at the simulation. And here you can see mass 1 and mass 2 are both 1 kilogram. Initial velocity 1 is 5 meters per second. Initial velocity 2 is negative 5 meters per second. Let's run the simulation. And you see that they did in fact bounce off of each other. And they moved away in the opposite direction at the same speed that they had. You can clearly see that the final velocities of both cars were opposite of what they were before the collision. So once again, we can see that these two formulas in the red box and blue box yield predictable results which are verifiable in the experiment. Let's try a new combination where mass 1 is at 5 and it is faster than mass 2, which is slower, and they're moving in the same direction. Fast hits slow. So the prediction for both formulas is that the v1 prime will become 2 meters per second after the collision, and the v2 prime will become 5 meters per second after the collision. It seems that their velocities switch. These are both moving in the same direction. So a fast car crashes into a slower moving car. The faster car slows down, the slower car speeds up. Let's take a look at that in the simulation. And here we are back in the simulation. We have the red car moving to the right at 5 meters per second and the blue car moving to the right at 2 meters per second. Fast car hits slow car. The prediction says that their speeds will reverse. The 5 will slow down to 2 meters per second and the 2 meters per second will speed up to 5. Let's run the simulation. And there you have it. Predictable results that are demonstrated in the simulation. Let's try a new situation. Instead of having equal mass cars, let's make mass 1 2 kilograms and mass 2 remains at 1 kilogram. So this is heavy hits light, except the heavy car mass 2 will be traveling at 5 meters per second and the lighter car will be traveling at negative 5 meters per second. According to our formula, the red and the blue yield v1 prime equal to negative 1.6 and the v2 prime will be 8.3 meters per second. Let's check this in the simulation. Here you can see the red car is 2 kilograms, the blue car is 1 kilogram, the red velocity is 5 meters per second to the right, the blue velocity is 5 meters per second to the left. Let's run the simulation and see what we get. And there you have it. This is the exact result that we determined before. The red car would ricochet backwards at negative 1.7 meters per second, and the blue car would ricochet backwards at positive 8.3 meters per second. Let's try a 3-to-1 mass ratio, and this time we'll make the v1 equal to 5 meters per second and the v2 will be equal to negative 5 meters per second. And you could see here that v1 prime is 0 and v2 prime equals 10 meters per second. So after the collision, mass 1 stops and mass 2 acquires a speed of 10 meters per second. Let's run that in the simulation. And here is the simulation. We have a 3-to-1 mass ratio. We have red car moving at 5 meters per second to the right, blue car moving at 5 meters per second to the left. Let's run the simulation and see that the red car stopped as predicted and the blue car moved to the right at 10 meters per second. As you can see in the elastic collision calculator, all the possibilities of masses and velocities are possible. You can use the calculator to determine the after collision velocities based on the conservation of momentum and conservation of energy. Obviously, there is no friction involved in these problems, so these end values are precise. However, in the real world, when there is friction, like in the collision of two cars or a truck and a car, you can see different results that are closely modeled by the perfect situation with frictional effects and crumple zones and heat, light, and sound energies leaking out, all taken into effect. The objective of safety engineering and automobile design is to prevent the loss of life of the driver and occupants of the car. All safety engineering looks at the best case scenarios to say if this car hits this car at this speed and that speed, these will be the rebound velocities and of course the rebound energies. The idea is to dissipate as much of that energy as possible, directed around the frame of the car and not through the occupants of the vehicles. This is to prevent the loss of life, as we mentioned before. I hope you enjoyed this exploration into the elastic collision calculations for the various combinations of two bodies in collision. This calculator is great to use in a lab setting with the air-track crash carts, but it's also very good when solving problems on a calculator. Thank you for watching, and I look forward to seeing you in the next video.